Welcome learners. So for this video, let's try to solve a question from KTU's 2019 December question paper for the first semester students in engineering graphics. So the question is, a line AB inclined at 45 degree to VP has its end 20 millimeter and 50 millimeter above HP. The length of its front view is 70 millimeter and its VT is 10 millimeter above HP. Draw its projections and find its true length, true inclination with HP, and also locate its traces. So as we know, this is a question from first module, uh, which is related to projection of lines inclined to both planes. So right from the question, we have this knowledge that the location or the shape or the projections of the line has already been given. The front view is fully given, and it's also its vertical trace has been given, and they are asking for to find its true length, true inclination with HP, and to locate the traces. So from that, we can imagine that they are asking for a solution using trapezium method, because they are asking for true length and true inclination with HP, and they have fully given the front view in the question itself. So we shall try to solve this using the trapezium method. So let's begin. Let's we draw the XY line. Okay, so let's first mark the reference lines so that we can uh, locate the point A. Okay, so it says that it is the VP is VP of A, or the location of A, for example, is 20 millimeter above XY line or above HP, and the location of B is 50 millimeter above HP. So they are both above HP. So what we have is here is the location of the points in the front view. So I'll draw a reference line here. (20 millimeter above XY line and 50 millimeter above XY line, and I'm arbitrarily choosing the location of point A. Okay, and this is A. I'll mark it as A dash because it is the front view, and they have also given the information that the front view is 70 millimeter in length. So what I'm going to do is I'll just cut an arc from the point A dash on this reference line. Okay, which means that this is our point B dash. Let's just mark it. Okay, and then I'm going to join these 2 points. Okay. If I'm marking the dimensions, this is 70 millimeter length, and this is 20, this is 50. So what else is given in the question? Let's see. So the length of the front view is 70 millimeter, so we have marked it, and they have given that the VT is 10 millimeter above HP. So let's draw another reference line so that you could try to find out the location of the vertical trace. So 10 millimeter above HP. So I'm going to draw a reference line at a distance of 10 millimeter above XY line. Okay, so VT is somewhere on this line. So what else do we know about VT? VT is obtained when we are extending this line. Okay, when we are extending this line towards one of the reference planes. So the VT is somewhere on this line, and also that line it is also on a line which is extending from the line A dash B dash. So it will intersect somewhere here, and we can just find out the location of VT. So let me just draw the extension. Okay, so the point of intersection here is our VT. Okay, now let us mark that point. All right. So we have located the point of the vertical trace. We have drawn the front view. Now let's see what all other information that we have here. So they are saying that the line AB is inclined at 45 degree to VP. So if it is inclined at 45 degree to VP, then the inclination between the front view and the line which represents the true length in trapezium method, that will the inclination or the angle between those two lines will actually give the inclination with the vertical plane. So that we know from the question that it is 45 degrees. So let's just draw a line at an angle of 45 degree from with respect to A dash B dash from VT. Okay, so if you are measuring this angle between these two lines, should be 45 degree. All right, then the next step would be to actually do what we do in the trapezium method. So we have to draw a perpendicular line to A dash B dash from the point A dash and one from the point B dash, and let's see where it intersects with the new line that I have drawn here. Okay, so we have drawn a perpendicular to A dash B dash at A dash, and then we shall also draw one at B dash. Okay, let's extend this to this point here, this line here. All right, so if we can join this using a thick line here, this is our true length. So let me just move this question so that it is more comfortable for me. Okay, so this is actually the true length. So let me name it A, capital A and capital B. Okay, so Now from this we have located its or drawn the line with its true length. So let us just measure it to see how much it measures. It measures 99 millimeter. The next step would be to actually draw the top view of the line AB. So for that we can again use the procedure that is used in the trapezium method. That is, we will take the distance A dash A and we will take the distance B dash B and we will transfer it below XY line. Okay, so the XY line is here. Let me just properly mark it. This is XY line. All right. So what I'm going to do is I'll measure this distance here and I will transfer it below XY line. Okay. Similarly, I will take this distance here and transfer it below XY line. Okay, I hope that is clear. So let me just mark the point. Okay, so I had measured around 23 millimeter distance with A dash and 93 millimeter distance with B dash, and I've just transferred that distance below the XY line in order to get the point A and point B. That would be our top view. So let me just mark that line here for you. If I'm marking this, this is the top view of A. This is the top view of B. As you can see, this is the top view. So with regards to the top view, we all know the fact that if this is correct, then this line, if extended towards the xy line, then it would meet at the point of the top view of vertical trace. So let's see if that happens now. Let's mark V. For that, I'm going to project this point downwards, obviously using a thin line, and let's see if this line, if extended, can meet at this point. Yes, definitely it is meeting at that point. So again, okay, so this point here is the V. Okay, so what else do we have to find out? We have already found its true length, and now we have to find the true inclination with the HP. So in order to find the true inclination with the HP, you have to repeat this procedure here. That is, we have to draw you have to take this distance here. Let me just do it. Okay, we'll take this distance and and we will transfer that distance to a perpendicular line drawn to AB from A. Okay, let me just do that for you then. Alright, so I have drawn a perpendicular line from the point A, and now I will draw an arc in order to transfer this distance, that is 20 millimeter, onto this perpendicular line. Okay, I have transferred that distance now. Now I will transfer this distance of 50 to a perpendicular line from the point B. Okay, so the perpendicular line has been drawn. Let me just cut an arc with a length of 50 millimeter. Okay, and let's just join it so that we get the true length. Okay, now let's just measure it. It should be same as the true length that we had gotten before. Okay, I need to just a little bit tweak this particular line. Yes. Okay, let me draw the dimensions. Yes, I've got the same value, that is 99 millimeter in this true length also. So we can be sure that this has been the proper solution. So again I have to mark the points. Okay, I will name this as, again I will name it as capital A, and this would be capital P. Okay, so this is the top view and this is the true length of the line with regards to the view from the top. Okay, so in order to get the the inclination of the line with the horizontal plane, all you have to do is you have to extend these two lines, capital A capital B and the small a small b. You have to extend this and see where it meets. That the meeting point would be the horizontal trace, and the angle of inclination between these two lines will actually give you the inclination of the actual line with the horizontal plane. So let's see what is the angle of inclination between these two points. Yes, this given as 18 degree. So let me also just extend this so that it meets somewhere. Just extend this. Okay, so they have intersected at this point, and that point would be our HT, or the horizontal trace. Okay, let me just mark that point also. That was our HT. And now if you have to find the H dash, that is the front view of the horizontal trace, then all you would do is draw a projector from the top so that it meets the XY line somewhere down here, and this would be our H dash. Okay, and if you are trying to extend this line A dash B dash, then as per our theory it should meet at H dash. Let's see if it meets us the H dash, and looks like it will actually. Yeah, it meets exactly at H dash. So this, our solution is complete now with regards to this problem. So the line AB was drawn. Um we have drawn its projections. That is, the top view has been drawn. The first front view was already given in the question, and we have found its true length. True length is 99. So we will just write it here. That is, true length will be equal to 99 millimeter. And if your inclination with HP, it will be 18 degree, right? It will be 18 degree, and we have also located its traces. So the entire question is solved, and you get 20 marks for this question. I think it will take around 15 minutes to solve if you have done really well. So this is particularly easy if you know the procedure or know the concept regarding trapezium method, and but still it is one of the toughest questions that you can get in engineering graphics. So Thank you for watching this video.